Hi, lovelies. Today we are going to talk about functions, what they are, and how we use function notation. Hopefully, again, this is a review for you. Make sure you write down today's date, stay organized. Okay, so a function is a special kind of relationship where every input gives you one and only one output, one specific output. So if you go to a soda machine and you press the button for Sprite and you get a Sprite, great. If you press that button for Sprite again because now your friend wants one and you get a Coke, not so great because maybe your friend doesn't want a Coke. I know I wouldn't want a Coke. So that is a not working machine because that button, that input, what you told the machine you wanted, gave two different outputs. Now, if the button for Sprite, you press the button for Sprite and it gives you Coke every time, at least you know what you're going to get after that first initial surprise, right? But it's one output only. You cannot get a Coke and a Sprite out of it. When we're talking about mathematical functions, if you were to draw a quadratic, for example, at every x value, the inputs, every x value, there's only one y value that corresponds, right? So an example that doesn't work is if we turn to that parabola sideways, right? Well, now if you think about the value of x at like -1, right? Well, that gives me a positive output and a negative output. That's not a function because I don't know what I'm going to get. So again, every input has to have one and only one output. So if you think about an XY chart, input is our X value, output is our Y value. So if we have 0, 1, 2, and 1, 2, 3, every input has one and only one output. However, if I were to do a similar chart over here and do 0, 1, and 1, 2, and 2, 3, and 0, 5. Well, now I have a 0 with an output of 1 and a 0 with an output of 5. And that is not okay because I want to know exactly what output I will get when I press that 0 button. So I cannot get two different outputs, one and only one output. All right, so what is function notation? It's just a way of writing this in terms of x and y a little bit differently. So what we're going to say is f of x. And what f of x, right over here, f of x means is the value of y. F of x is just y in its fancy function clothes. The value of y, that's what f of x means, the value of y at a very specific x point, in this case, x, right? But later we could say f of 3. And now what that's saying is I want the y value that corresponds to the x value of 3. What's the value of y when my input is 3? So that's what function notation is telling us. Now, if you go down here and you say f of x is 10, that's what equals means is, right? F of x is 10. Then what I'm telling you is f of x, that y value, y is equal to 10. Go ahead and solve for that missing x piece. Now what I'm asking you to find is what's the value of x that would make the overall y value equal to 10. All right, so let's look at an example. If we are given the function 3x squared plus 4x minus 7, and we want to find f of 0. So what we're asked for is the value of y when x is 0. This is actually asking me for my y-intercept. So based on what I know about a quadratic, I'm expecting an output of -7. That's my y-intercept. But I'm going to do the math anyway, just to double check. So my input, my x value is going to be 0. 3 times 0 squared plus 4 times 0 minus 7. Well, these go away because anything times 0 is 0, and I'm left with -7. So that means when x is 0, y on this function is going to be -7. So this gives you an ordered pair, a specific point on the function, the x and y, the corresponding values there together. Okay, slightly different. Now they're telling me, what's the value of x that makes y 0? What's the value of x that makes y 0? So now I'm solving for y-intercepts here. Slightly harder math because now I have to say 0 equals 3x squared plus 4x minus 7. Hopefully this looks really familiar. To solve something like this, you're going to have to factor. So a little bit more complicated to solve for the x values than to solve for the y values. All right, so in this set of examples, we are supposed to determine if the relationship is a function. If not, you're supposed to identify why. All right, so in my first example, This is not a function because I noticed that every single input between -5 and +5, between the domain there, every value in between gives me 2 outputs. Not okay, because I don't know what I'm going to get. At 0, I could get positive or negative. At 1, I could get a positive or a negative. Not a function. And the vertical line test proves it out. So I would just highlight, like, look, 2 outputs for the same input. Not okay. All right, in my table example, I really want to focus on these inputs and see if any repeat. Because if any of them repeat, that's a red flag that I need to double check that the output is the same at those points. If they're different outputs, that is not okay. So when I look at this and I have each input value, I notice none of them repeat. Therefore, this is good to go from what I can see in the table. Again, other values could pop in that I didn't know existed that could make that table not a function, but the table I'm given is. All right, your turn to try. Okay, if we try this one, vertical line test shows that every single input has one and only one output. Yeah, that's a function. Let's look at our table here. So we're looking at inputs. None of them repeat, so we're good. But if you accidentally looked over here and noticed, oh, look, I have 6 twice, and it's different input values, that's fine. That's like a parabola, right? So if you think about it over here, right there, we have 2 different x values for the y value that we're given. But that's fine. There's nothing wrong with that. It's all about x, our input, having one and only one unique output. All right, now let's practice function notation. Give this a shot. So our first example, we are trying to find f of 2. So again, that means what is the value of y when x is -2? So I'm going to plug in -2 for x. 3 times -2 squared. Make sure you put that -2 in parentheses. You're squaring that whole value. That's going to make it a positive, minus 8. So what I end up with, order of operations tells me to do my exponents first. So I get 3 times 4, positive 4, which is 12, minus 8 equals 4. So I know that f of -2 equals 4, which means when I plug in -2, my output will be 4. That is the ordered pair that represents that point on the function. Okay, now in the second example, I am finding the value of x if y equals 2. So now I'm going to say 2 equals 7x minus 12, and I need to solve. So inverse operations, and I get 14 equals 7x, divide by 7, x must equal 2. So again, the ordered pair is going to end up being 2, 2, because both values are 2. All right, your turn to try. First, we're going to do 1/2 of 5 plus 7. Half of 5 is 2.5 plus 7 is 9.5. So when I plug in a value of 5, my output is 9.5, or my y value there. In this case, I have -3 equals -3 over 4 times x plus 3. Inverse operations again. -6 equals -3 over 4 times x. To move this entire fraction all together, I'm going to multiply by the reciprocal, right? So my 3's would cancel and my 4's would cancel. So over here, of course, I do the same. -4 over 3. -4 times -6 is positive 24. 24 divided by 3 is 8. So x must equal 8, which means when I have an input of 8, I have an output of -3. Again, you could check these, plug them back in, make sure that they work out, but they should. And hopefully that is a review for this section. Remember that you're doing all of your summaries after these. Summaries are a really important part of this class. Take those seriously. Ask for help in your Campfire groups if you need it. Hope you're doing well.